everyone, and welcome back. In this lesson, we're going to explore triangles. Triangles are some of the most important shapes in geometry. They are simple enough for young children to begin working with early, but they also contain deep mathematical ideas that continue throughout later mathematics. As future elementary teachers, it is important not only to know the names of different triangles, but also to understand how those classifications work and how they connect to one another. And as always, remember, you do not have to master every idea immediately. We are building understanding piece by piece, and that is exactly how meaningful mathematic learning happens. Let's begin with some definitions. A scalene triangle is a triangle with no congruent sides. That means all three side lengths need to be different. An isosceles triangle is a triangle with at least two congruent sides. Many students first think of isosceles triangles as having exactly two equal sides, but it's helpful to keep in mind that an equilateral triangle also has at least two congruent sides. Depending on how classifications are handled, that can matter. An equilateral triangle is a triangle with three congruent sides. And because the three sides are equal, all three angles are also equal. This is our regular triangle. Now, let's look at classifying triangles by their angles. An obtuse triangle has one angle that is greater than 90 degrees. A right triangle has one angle equal to 90 degrees. An acute triangle has all three angles less than 90 degrees. Now, here's an important idea. Not all combinations are possible. For example, there is no equilateral right triangle. Why not? An equilateral triangle has three angles. Since the angles in any triangle add to 180 degrees, each angle in an equilateral triangle must be 60 degrees. The total 180 degrees of the triangle divided by the three angles. But a right triangle must have one angle equal to 90 degrees. A triangle cannot have all angles equal to 60 degrees and also have one angle equal to 90 degrees, so an equilateral right triangle is impossible. This is a great example of how definitions interact. Some combinations work and some do not. For example, isosceles in right is possible. A triangle can in fact be both. Isosceles and acute is also possible. A triangle can be both isosceles and acute. Scalene and obtuse is also possible. And scalene and right triangles are possible as well. Equilateral and right is not possible, as we discussed before. An equilateral and obtuse is also not possible. Every triangle in an equilateral triangle is 60 degrees, so every equilateral triangle is always acute. That's a very useful relationship to notice. I looked at 6 different options here, but we are missing 3, equilateral and acute, scalene and acute, isosceles and obtuse. I encourage you to try to see if those are possible or not. As future teachers, this is an important moment to help students understand that classifying shapes is not just about memorizing vocabulary. It's about reasoning with properties. A good idea to ask students is, what do we know must be true if a triangle is equilateral? Or, what do we know cannot be true if a triangle is right? Those questions help students connect definitions instead of keeping them separate. Nice work. This is the foundation for the rest of the lesson. In the next video, we'll look at an important relationship in triangles, how angle size and the side length are connected.